Imagine floating in the cold, silent vacuum of space, staring down at the largest object in our solar system, Jupiter. It is a swirling, violent storm of hydrogen and helium, so massive that more than 1,000 Earths could fit entirely inside it. Just looking at its monumental scale triggers a deep sense of megalophobia, that primal, unsettling fear of impossibly huge things. Before you even reach the atmosphere, the environment is already lethal. Jupiter is surrounded by invisible radiation belts so intense they would destroy normal electronics in seconds. But what if you somehow bypassed the radiation? What if you didn't just look at this massive world? What if you fell in? We are taught in elementary school that Jupiter is a gas giant, a fluffy, beautiful ball of swirling clouds with absolutely no solid surface. So, if there is no ground to hit, what exactly happens to you? Do you just fall through it forever? Do you shoot out the other side like a bullet through a cloud? Or do you eventually hit some kind of hidden bottom? To find out, we have to build an indestructible submarine, seal ourselves safely inside, and drop directly into the violent eye of the storm. The drop begins. Immediately, your submarine is swallowed by the violent upper atmosphere. The winds here are tearing past your hull at over 600 kilometers per hour. The sky outside the viewport is a blinding, high-contrast canvas of swirling white and ammonia ice blue, illuminated by constant, massive, and terrifying lightning strikes. You are falling fast. But as you sink deeper, the light begins to fade. The beautiful blue clouds turn a bruised, toxic purple, and then a thick, muddy brown. The temperature outside is rapidly rising. The pressure is steadily building against the glass. At 156 kilometers down, you pass a ghost in the dark. This is the exact depth where NASA's Galileo probe met its violent end in 1995. The intense pressure crumpled the probe's titanium hull, effectively disintegrating it into the atmosphere. If our submarine were not entirely indestructible, our journey would end right here. But we keep sinking. And down here in the pitch black, the environment begins to behave very strangely. We are now 1,000 kilometers deep. The pressure is hundreds of times greater than at sea level on Earth. You might expect that as we continue to fall, we would eventually hit a massive, churning ocean of liquid hydrogen. You might be bracing for a massive splash, but there is no splash. Notice how the darkness outside the window isn't just dark anymore. It is thick. Under this extreme hydrostatic pressure, hydrogen undergoes a bizarre, continuous phase transition. It becomes a supercritical fluid. This is an entirely alien state of matter, where the physical boundary between a gas and a liquid completely ceases to exist. There is no distinct transition. The fluid density increases so gradually that there is no surface to break. The gas simply gets squeezed so tightly that the molecules lose their distinct boundaries, seamlessly and smoothly thickening into a pitch-black syrup. Imagine a normal submarine hitting the ocean on Earth. It breaches the surface, splashes, and sinks. But here, the air itself just smoothly thickens into an ocean without you ever crossing a boundary. You are now sinking through a suffocating, pitch-black void. The pressure is groaning and thumping against the hull. We are 20,000 kilometers down, and the crushing darkness is about to end. But not because we found the bottom. The pressure outside the submarine has now reached an incomprehensible 2 million bars, 2 million times the atmospheric pressure of Earth. Under this much immense force, the standard rules of chemistry literally break down. Watch what changes in the environment around us. The pressure is so intense that it shatters the bonds of hydrogen molecules. The protons remain fluid and moving, but the electrons detach entirely, flowing freely through the liquid space. In an instant, the pitch-black, syrupy fluid erupts into a blinding, churning, electrically charged ocean of liquid metallic hydrogen. You are no longer sinking through gas. You are sinking through a glowing silver ocean of liquid metal. And because this metallic ocean is constantly swirling and churning, those millions of free-flowing electrons generate a colossal electrical current. This is the planetary dynamo. This glowing metal ocean is exactly what generates Jupiter's massive magnetic field. But the weather here is completely alien. Look at the bizarre precipitation falling past the glass. Because helium cannot mix easily with metallic hydrogen, it condenses. It is raining neon and helium deep underground. Droplets of heavier elements are falling through the metallic fluid and plunging into the abyss like glowing alien rain. We have descended tens of thousands of kilometers. The atmosphere became a liquid without a single splash. The liquid became a glowing metal. But the ultimate question still remains. After all this terrifying depth, is there an actual solid rock at the center of this planet? We reach 60,000 kilometers deep, the core. You brace for impact. You expect the indestructible submarine to finally crash into a dense, solid, terrestrial sphere of rock and ice. But there is no crash. Instead, your descent simply slows down. The metallic fluid around you becomes denser and denser until the buoyancy perfectly matches the immense weight of your submarine. You stop sinking. You are perfectly suspended, floating weightless in an abyss that is blazing at 24,000 degrees Celsius. That is significantly hotter than the 5,500 degree surface of our own sun. And as you look around, you realize the shocking truth about Jupiter's core. It isn't a solid rock at all. It is fuzzy. Recent data from the Juno spacecraft reveals that Jupiter's core is incredibly dilute. Think of a giant antacid tablet dissolving in a warm glass of water. The heavy elements, the ancient rocks, and the exotic ices that originally formed the seed of this giant planet may be eroding and mixing into the metallic hydrogen ocean around it. There is no bottom to hit. The floor itself is dissolving. This terrifying, beautiful descent isn't just a wild thought experiment. It holds the keys to understanding our own future and our ancient past. By understanding how extreme pressure forces hydrogen to shatter its bonds and become a metallic conductor, scientists hope that tracking this behavior may help guide the creation of room-temperature superconductors right here on Earth. If we can master the exotic physics happening inside Jupiter's metallic ocean, we could build completely lossless energy grids, revolutionize global transportation, and upgrade modern technology overnight. And that fuzzy, dissolving core, it tells the violent story of our solar system's birth. It shows us exactly how giant planets consume their own rocky seeds over billions of years, reshaping the delicate orbital mechanics that allowed a tiny, rocky world like Earth and humanity to exist in the first place. We are taught to think of planets in incredibly simple human terms. We stand on solid rock, we swim in liquid water, and we breathe invisible gas. But the universe is vastly more strange and complex than our terrestrial experience allows us to see. If you fell into Jupiter, you wouldn't fly cleanly through a cloud of gas, and you definitely wouldn't splat against a rocky floor. You would sink through a continuous, seamless transition from violent storms to suffocating dark fluids, eventually floating completely weightless in a blinding, raging ocean of liquid metal, entirely suspended within a dissolving planetary heart. Jupiter isn't just a fluffy ball of gas. It is the deepest, most extreme metallic ocean in our solar system, where the standard rules of reality simply cease to exist.